Hi, this is Sung. I'm your online maths mentor, and in this episode, welcome to episode number 13, right? Because in this episode, what I want to do is continue on with properties of a tangent to a circle, and in this episode, the theorem is this: two tangents drawn to a circle from an external point are equal. Okay, or another way that you can say this is that where you have two tangents, one tangent here and another tangent here, that are tangents to a common circle, right? Then the distance of those tangents to the point where they meet, to the point of contact with the circle, is going to be equal, right? So can you see that this distance AC is going to be equal to this distance CB? Right? You might not be able to see it straight away. You can kind of sense that would be the case, but we're going to prove it. And the way we prove this, of course, would be congruent triangles, because you can see you've got one triangle here and you've got another triangle here. Right? Now, do you remember that with congruent triangles, there are the four tests? There are four tests. The first test is SSS, which stands for side, side, side. All right, so you're going to try and prove that in the two triangles, all three pairs of sides are going to be equal. The second one, of course, is SAS, AAS, and the fourth one is RHS. Now, for this one here, what I want you to notice is that the radiuses are going to be the same. They are both going to have right angles at the point of contact, right, with the radius, with the radii. And you will also notice that this line is going to be common. So the interval from the center of the circle all the way to the point where they meet, or where the two tangents meet at point C, right? That's going to be common. So here you've got right angle, hypotenuse, and side. It's going to be the RHS test. Can you see that? So basically, I'm just going to show you how the proof will look when it's set out properly. Okay, so basically you're given that what you're given is two lines A and C that are tangents to a common circle with center O and radius R, such that AC meets BC at point C. Okay, so that's what you're given. The aim is to prove that AC, which is this distance here, is going to be equal to BC, which is that distance there. And like I said, you're basically going to be using congruent triangles, and it's the RH test that will satisfy the proof, okay, that those two triangles are congruent. All right, you've got the intervals. What you want to construct is the intervals OC. You want to construct OC, that line there. You want to construct OA, which is that interval there, and OB, which is that interval there. These two are both going to be the radii of a circle, right? So they're going to be equal. So here's how we start off our proof. In triangles AOC and BOC. So AOC and BOC. So they're in those two triangles. What we know is that angle OBC, OAC, let's start with OAC because that's the triangle that we first mentioned. AOC is equal to angle OBC, which is equal to 90 degrees. And the reason why is it is the angle of tangent with the radii of a circle. Now, the second thing, R, so that's R. I'll do this with a red pen. The next one is H, right, which is OC is equal to OC. Now, why is OC equal to OC? Because it's common side. When you just write common, right? And the last one is OB is equal to OA. Does that make sense? Now, why is OB equal to OA? Because they're the radii of a common circle. Okay, so there we have it. You've got RHS. Therefore, triangle AOC is congruent to, and it's basically an equal sign with an extra line on the top, is congruent to triangle BOC, and the reason is RHS. All right. Now, because these two triangles are congruent to each other, we can then go that extra step and say BC is equal to AC, right? Therefore, BC Oh, hang on. Let's make it AC. AC is equal to BC. Okay, and the reason why is congruent triangles. AOC is congruent to triangle BOC. Therefore, theorem 13 is all right. So, does that satisfy your proof? All right, so that satisfies the proof, right? So yeah, so we can see that theorem 13 is true simply by going through congruent triangles, showing that this triangle here is congruent to this triangle here. Therefore, these two sides are going to be equal. So let me just write that down. Excellent. Thank you very much for watching. Bye.